Okay, so hi students. So I was supposed to cover decorators, but before diving into decorator, I have thought that there are some prerequisites that I need to cover first before diving into decorators. So these are the subtopics that I'll be covering. What is decorator? Different kinds, use, examples. Now, as I said, there are some prerequisites that we should know before knowing the concept of decorators. So that is the reason I have divided the whole topic into two videos. So this is the part one, and in the next video I will be talking about the rest portion. Okay, so let's start with today's discussion. So the first thing I want to say is there is a so this is the first thing of that I was talking about, the prerequisites. Okay, so there is meta programming. So what is this? So this is a programming technique. Uh, what it says is meta programming is a concept which talks about modifying a part of the program from another part at compile time. So this is a programming technique. Okay, so this is not, as I say, this is a concept. So we can implement this in different languages in different ways. Okay, in Python we can implement metaprogramming either using meta classes or using decorators. So there are ways. Okay, so in I mean in today's video or in the next video, I'll be talking about decorators. So we'll learn about how we can implement metaprogramming through decorators. Okay, so next thing is, so the uh, what should I say? First subtopic is subtopic of subtopic. Okay, so what is callable? So as the name suggests, callable is that can be called. Okay, so but that is very oversimplified version. But let me explain it through examples. So let's say I have a function. This is the function demo callable func, which does nothing basically, which just returns zero. Okay, now as I said, in Python everything is object. Okay, so there is a function, it is a class, everything is object. So as I said, class is also an object. Class is an object of type class. Okay, so yeah, what is callable? So as I was saying, this is the function, and this is a number, num equal to 5, and this is another a class. Okay, class, demo callable class. uh, Inside that class we have two functions. One is underscore call, and one is do something. So inside underscore call we have a print statement, do something, and inside do something we also have this print statement, do something. Okay, now what I want to explain is, if I print callable demo callable func, so this demo callable func, we know we can call this function. Okay, using so if I just write, so if we do like this, it would call this function. So this function can be called, right? So this is a inbuilt method in Python. uh, with the help of this we can check whether an object is callable or not. Okay, so as we know we can call a function. So if we print this, it will return true. Okay, now as I just uh, showed you that this is how we call function. So this is nothing but, if we do like this also, same thing. Okay, a different way. So yeah, similar to demo, as I said. Next thing is, as we know, this num is not callable, right? We can not call it. So obviously it would return false. Next thing is callable demo callable class. So now the new thing is, we can, this class, any class, this is a demo class. So any class is callable. Okay, whether we define this function underscore call or not, that is the different thing. That just gives an add-on. Okay, so even if we don't define this, still this is callable demo callable class would return true. Okay, I will talk about what is the internal working, but yeah, so this would return true. So now, if we create an object of this class, so this is how we create objects. Now the difference comes, if we define this underscore call method inside class, this line this line won't give any error, okay, because as I said, this is nothing but, right? So this object would find that there is a function called this, so it would call this and do something would be printed. But if we don't define this underscore call, still we would get return true. But if we create object, this line would give error, okay. Now what is happening behind the scene? So the sequence of execution is like this. Demo callable class, the example that I have chosen, demo callable class is object of type class. As I said first, that everything is object. A class is still an object. So this is every class is object of type class. So when you do like demo callable class, this is how we create objects of a class. It is nothing but demo callable class dot call, as I said. Okay. Inside call, now the main part is, here we have defined this call method inside this class. But as I said, even if we don't define this, callable would return true. Why? Because this demo callable class inherits properties of type class, and there is a function called underscore call in type class. So that is the reason. Now inside that call method, which is defined inside type class, so inside that call of type class, it first calls underscore new. Okay, so the first step is it calls underscore new, which allocates memory in heap. So this basically returns nothing but an empty object. Okay, and then from that underscore call, it then calls underscore init method to initialize it, and at last the object is returned. So this is how how this is going behind the scene. Okay, this is the sequence of execution. First it calls new, then it calls init. Okay, now the next thing is I want to talk about these functions or objects. Okay, names or identifiers bound to those objects. So what does it mean? It means, so this was our function, demo callable func. So if I do like this, like we do in case of variables, so if we do like this, so it's nothing but copying an object. Okay, so you can think of like this. In heap memory, we have one object and two names are pointing to one object. Okay, so different names can be bound to one function object, as I was talking about. So print, so this would do the same thing. If we do like this, demo callable func, calling this one or this one is same. So that's the thing. Next thing is functions can be passed as arguments. Now let me talk about this example. So here I have defined this function, demo main function, which takes three arguments. First is argument function 1, argument function 2, second one, and check variable. So these, as the name, you can guess that these two will be functions, and this one would be some variable, whether it is a boolean or int. That's another thing. So if check var, so obviously I'm giving a boolean variable. So I'm checking if check var is true, then I would call this function. If false, then I would call this function. So a simple example. Now you can think that we are passing function as arguments. So if we call like this, demo main function, this was our function. First argument, I am using a lambda expression here. So it is just a function that has a print statement in its body. So this is the first argument inside first argument function, and second function is inside second argument function, and this check var is false. So this is basically this first lambda, this is basically the second lambda, and check var is false. Now if I call this, as I am passing false, so this would, if this is not true, so else, so it would call argument function 2, that means this one. So inside second argument function will be printed. Okay, so the next thing is functions can be defined inside another function and returned from that function. Let me take an example. So let's say I have this parent function, demo parent, which takes a boolean variable, check var, like the previous one, and inside that parent function we have two child functions. Okay, so the first child function, inside first child function we have a return statement that returns inside first child function a string, and this returns inside second child function, and if we are checking this check variable, if it is true, then we are returning this function object. Okay, we are not calling it, we are returning this object, and else we are returning this object, this second function object. Now if I call demo parent, okay, and pass false as its argument, so return second, so this will be executed, so second child function, so this will be returned. Now demo parent result, I mean calling this demo parent result or calling this would be the same thing as I was talking about earlier. So print, if I call this, it would print inside second child function. Okay, now the next topic is, the next subtopic is closures. I mean, what is closure? So the first thing I want to say is there is a concept of non-local variable. So there are three scopes. First is global scope, local scope, and non-local scope. So non-local variables, I mean, this comes totally when you talk about closures. So if we have an outer function and inside that we have a nested function, so the concept is nested function can access variables of outer functions. Okay, so for example, inside this example as I have taken here, so I have defined a function demo parent function. So this takes this message as its argument. So this message is a variable of the outer function or the parent function, right? And inside this parent function I have defined a nested function or child function you can say, and here I am printing message. So now you can understand that this message is still accessible from nested function. I mean, instead of, I mean, even if it is a member of or the variable of outer function. Okay, so now, but the concept is it is only read only. Okay, I mean you cannot, I mean it is not writable, but if I want to make it writable I have to define it as non-local variable. Okay, so if I do like this, I mean before printing, if I do like this non-local message, so if I do like this, now I can, I mean I am just making this readable variable writable through this keyword non-local. Okay, so this is a concept. Okay, so the, I mean the, if I was talking about closure, so this was our example. Now inside, I mean after defining this nested function, what I'm doing, I'm calling this function. I mean I was still in the outer function, I'm calling this function, this nested function, and after calling this function I'm just returning the nested function. Okay, this object, the function object, I was returning this. Now first statement, what I'm doing, demo parent function cp equal to, I'm calling this parent function and passing hello world as its argument. Okay, I mean now what will happen, it will call this function, this message will be equal to hello world. Here it will I mean if I just comment out this, so it will print hello world. I mean this is the definition obviously, but when you call, I mean in this statement demo nested function we are calling this, so it will print hello world, and after that we are returning the object. So in this line it will first print first time hello world. Okay, and this demo parent function cp will become the object, this demo nested function. So in the second line when you are calling this, so it is same as calling demo nested function like this one, so it would again print hello world. Now the main thing is of closure is, even if I delete demo parent function, this function, the concept is this message or this hello world is still attached to this copy function or the demo parent function cp. I mean this is still attached to it even if we delete the parent function. And that is the reason why if I call this one again like this one, it would still print hello world. Okay, and if I want to see, I mean what are the contents of closures, so I can do like this demo parent function cp, so this is the object, it has a property called dot underscore closure, and the first element is, I mean, zeroth index element is, and there is a property called cell contents, so it would return the content, in this case hello world. So I mean, let me run this, then it would be clear more. Okay, now so if I run this, see, 4 hello worlds. Now let me explain last time. So first hello world is for this calling, okay, this calling. Second hello world is for this one, so it would call this one, so it would print hello world. Third calling is, third printing is for this one, and fourth is for the content showing. So that's all about today, and in the next video I will be covering the rest portion, so I will straight dive into the decorator portion, okay. And I will upload this code on GitHub, so you can access it. I will provide you the links in the description. um, Stay healthy, keep learning.